Let's dive into learning how to solve some basic trig equations. We will be doing 5 problems on today's lesson. Problem number 1, square root of 3 times the cotangent of theta minus 1. When you have an equation given and there's only one term mentioned of a trig function, our goal is to solve this equation by isolating that mentioned trig function. So I am going to want to get cotangent theta in this problem all by itself. So I want to isolate my trig term. Okay, that's going to be the goal. My trig term, the cotangent theta, needs the -1 and the square root of 3 to move to the other side. Okay, on this side, the left-hand side of the equal sign, I only want cotangent theta being mentioned. So we need to undo certain operations in order to move those terms over. So between square root of 3 and -1, we are going to move the -1 first. We are going to add 1 on both sides so that when we do that, the -1 on the left-hand side of the equal sign will end up zeroing out because -1 plus 1 is 0. Everything else, square root of 3, cotangent of theta equals 1 will come down. Now let's proceed to get rid of square root of 3. What is square root of 3 doing mathematically to cotangent theta? It is multiplying. So let us divide both sides by square root of 3. Whatever you do on one side, you must do to the other side. And again, in doing so, square root of 3 over square root of 3 reduces to 1, and you're left with cotangent of theta equals to 1 over square root of 3. If you look on your formula chart, you will note that the definition of cotangent of any angle is obtained when you take your x value and divide it by the y value of the coordinates on your unit circle. So we are needing to figure out what angle, okay, on the unit circle, when we divide its x and y coordinates, will give us this answer. So let's go do that. Let's go to our unit circle. Okay, so again, cotangent theta is x over y, and the angle we want is having to generate an answer of 1 over square root of 3. Now here's a good example of where we can use process of elimination to help narrow down our answers, okay? Right now we have all these angles, okay? And by the way, we're going to focus on angle measurements in radians. So the ones I'm highlighting, those are the answers that I'm interested in trying to figure out. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 answer choices that we need to choose from. So of those 16, what is cotangent theta equals 1 over square root of 3? So what we want to narrow down is that our answer must have a square root of 3. So with that being said, the only answers or the only angles that involve a square root of 3, if you look at right here and right here, this has a square root of 3. This, hold on, let me freeze my screen. Okay, that has a square root of 3. This, oh my goodness, why is it not locking? Okay. This has square root of 3. This has square root of 3. All right. All these have square root of 3s. Okay. So what that means is that our angle choices have been reduced to pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, and so forth. Okay. Because those are the only ones that have square root of 3. Now, the next thing I want to do is notice that my cotangent is a positive value. It's a positive value. So when I divide x and y, as the formula says, my answer should be positive. Well, I know that my values of x's and y's in the first quadrant are positive here. So quadrant 1 definitely is going to be an option. But if I divided x divided by y here and x divided by y here, I'm definitely going to get a negative answer. Okay, because a negative and a positive will give me negative. So I'm going to erase these answer choices as possible ones. How about the third quadrant? Well, we have a negative and a negative, a negative and a negative. So if I did the x over the y, negative divided by negative, I would get a positive. And in the fourth quadrant, we're going to erase this. Same reason with the second quadrant, a negative and a positive combination will always give me a negative answer. So notice how from 8 choices, I've narrowed it down to 4. So let's figure this out. I need to divide x divided by y. So if I look at this angle right here first, this is my x, this is my y. So is square root of 3 over 2 over, that's my x, my y, 1/2, going to reduce to 1 over square root of 3? Well, watch how I do this. Square root of 3 over 1 and square root of 3 divided by 1 is square root of 3. That is not the same answer as that. So this here, x over y, is not going to work. So if that doesn't work, automatically, if I go from this angle over here, that automatically says that this one's not going to work. Okay? So we're left with the other 2 chances, and let's do the math. So x divided by y, so in this case it's 1/2 over square root of 3 over 2. Well, the denominators are the same. So now I'm left with 1 over root 3. And that is identical to that. And what angle were we standing at? At pi over 3. So if you take this and you go across, 4 pi over 3 would also work because of the pattern of symmetry, right? And negative divided by negative is positive. So my answers are 4 pi over 3 and pi over 3. Okay, so I've boxed in the answers that we obtained from the unit circle. Okay, so let's go to number 2. Cotangent squared theta minus 3 equals 0. So again, when we look at this problem, there's only a single term of trig mentioned one time. So we will just go ahead and proceed to isolate cotangent theta. We need to clean up by getting rid of those 2 values. So the first thing we're going to do is add 3. Once I add 3, cotangent squared theta will come down. Then minus 3 and the positive 3 zero out. And 0 plus 3 is 3. To get rid of a square, we will square root each side so that the square and the square root cancel. And we're going to end up with cosine theta equals plus minus the square root of 3. Now I need you to remember that you must always put plus or minus, and here's a little example why to help you understand. if you were solving for x and you had x squared is equal to 4, you would, as we just did, square root both sides. But most students usually just go square root of 4 is 2, which is obviously correct. But what I need you to get in the habit is when you take the square root of both sides in an equal sign, you must say plus minus whatever your simplified answer is. The square root of 4 is plus minus 2 because a positive 2 times a positive 2 yields a 4. A negative 2 times a negative 2 also yields a 4. So please make sure not to forget plus minus when you do these type of problems that involve square rooting. What does that plus minus square root mean? Well, it means that you are actually going to divvy up this equation into two separate equations. Cosine theta is equal to positive square root of 3, or cosine theta is negative square root of 3. Okay? And I switched it to cosine when it's cotangent. My apologies. Okay, so we know that, again, cotangent theta is the x over y variables, right? So, and I say variables, but it's not variables, values. So we're going to go to the unit circle and try to figure out where does cotangent theta, when divided by x over y, you would get square root of 3 or positive 3. Okay, so when we are doing square root of 3 again, so we can see that we only have some choices. So I'm going to go back to highlighting my choices that have square root of 3 in them, okay? So these are the choices that I have. I'm trying to get cotangent theta equals positive square root of 3. Now, positive cotangent and tangent values are only going to happen in the first quadrant and in the third quadrant. So I'm going to erase these yellow ones here because I want positive values. Okay, square root of 3 is positive. Now, cotangent is x over y. So what I need to do is take my x values and divide it by my y values to see if I get square root of 3. So let's do the first one. I'm going to look at this one right here. If I take the x, which is square root of 3 over 2, and divide it by 1 over 2, so square root of 3, square root of 3 over 2, over 1 over 2. Again, that's my x and that's my y. The 2's in the denominator cancel, and I get square root of 3 over 1. And square root of 3 over 1 is 3 square rooted. And that's exactly what I wanted, correct? So that means right off the bat, this one works. And if that one works, slide over to the other side, and that means the other one's going to work. Okay? So pi over 6 and 7 pi over 6 are the answers for this one. Okay, the other one would not have worked because if we did x over y, it would be 1 over square root of 3. Sorry, well, that's what the final answer would be, but the x is 1/2 over the square root of 3 over 2. When I cancel my 2's, you would end up with a 1 over square root of 3. And if you end up with a 1 over square root of 3, you would have to rationalize, because no denominator radicals. Square root of 3 over 3 would be your final answer, because 1 times square root of 3 is square root of 3, and square root of 3 times square root of 3 is just a 3, because square root of 3 times square root of 3 is a square root of 9, okay, which yields a 3. So that's not what we wanted. Square root of 3 over 3 is not matching our square root of 3 cotangent. With the same thought process of the previous problem, this time now we're looking for the negatives, so I have circled the negative possibilities, but we're looking to divide x over y to get negative square root of 3. So again, if I look at my x over y, my x is negative 1 over square root of 3. That's not going to work. How about negative square root of 3 over my 1? That does work. So my answer of 5 pi over 6 would pair up with 11 pi over 6 to get those answers. So theta is going to be 5 pi over 6 or 11 pi over 6. So the solutions to this equation are all 4 of those. So wrapping it up in one answer, your theta for this particular equation has 4 answers, 4 solutions. Here's number 3. 4 times the sine squared theta plus 2 times the sine of theta equals to 0. So look at the difference of number 1 and 2 when compared to number 3. You're going to notice now, unlike number 1 and 2, you are seeing trig terms occur more than once. When that happens, I want you to apply what we call the U substitution method. And it's a form of rewriting, okay? So I want you to, in your notes, so what you're going to do is rewrite, letting U be sine theta, because that's the term that's mentioned more than once. When you do so, every sine theta is substituted. So instead of 4 sine squared theta, you would write it as 4u squared. 2 sine theta is rewritten as 2 times u. And you set it equal to 0. So it looks like a basic algebraic equation. When you are solving equations that are squared, as in 4u squared, the first line of approach always is to try out if you can factor, okay? And of the factoring methods, I want you to always try the GCF, the greatest common factor, first, okay? If you look at this problem, your GCF, or the highest number both of your terms are divisible by, okay, is the number 2 as far as coefficients are concerned, right? And they both have a variable of u. So let us identify our GCF in this problem as 2 times u. So I am going to, in essence, divide my terms by that greatest common factor so that I can rewrite it in factored form. So write out your GCF. My GCF is a 2u. Whatever you're dividing both terms by, that's what you write it down. Okay, so this here is my GCF. And then inside the parentheses, I'm going to put the result of the division of the problem below, above. So 4u squared divided by 2u is a 2u. 2u divided by 2u is a positive 1. Okay? And if you distribute, you will notice that you end up right back where you were. 2u times 2u is 4u squared, and 2u times 1 is 2u. Once you have factored, I want you to apply the zero product property. So what you're going to do is take the products of your factors and set them equal to 0. So visually, what does that look like? This 2u needs to be set equal to 0, and 2u plus 1 needs to be set equal to 0. And we are going to isolate your u. Solve for u. I need to divide both sides by 2 to get u by itself, right? So u is 0. 0 divided by 2 is just 0. I need to subtract 1 on both sides on this one, which ends up being 2u equals negative 1. And then what do I need to do? Divide by 2 on both sides. That's correct. So we get u equals negative 1/2. Once your u is isolated, I need you to go ahead and rewrite it back into the terms of the trig function. So what we did is replace the u with sine theta back again. And so sine theta equals 0 and sine theta equals negative 1/2 are the trig functions we are going to solve for. So let's go to our unit circle. Where is sine theta equal to 0? Where is sine theta equals to negative 1/2? Now what you have to remember and look on your formula sheet is that sine theta is equal to the y coordinates of the unit circle, okay? So I'm needing to just look at the y coordinates. So let's do the first one. Where are the y coordinates 0? Well, the y coordinates are 0 right here and right here, nowhere else. Okay, that's the x and that's the y. This is the y right there. That's the y, that's the y. So I am going to say that theta, my angles occur at 0 radians and pi radians because we are working in radian mode. Let's do it again. Where are the y values going to be negative 1/2? Well, if I look for negative 1/2, y is negative down here. So there's an option. And here's the other one. Okay. My y is negative 1/2 and negative 1/2. So the angles I'm going to choose are 7 pi over 6 and 11 pi over 6. And you're done. That's the answer to number 3, those 4 solutions. So going back to question number 3, here are 4 answer choices. Let's tackle number 4. Number 4 is cosecant squared theta minus cosecant theta equals 0. Here's another example where we have more than one trig function. So that means we are going to resort to using u substitution. So I'm going to establish over here on the right that u is equal to cosecant of theta. Let's rewrite. Okay, so u squared minus u equals 0. Again, always try to factor using GCF first, okay? Every single time, always try factoring by greatest common factor. If you look at our particular problem, our GCF for this problem is going to be u. Both those terms are divisible by u. So I'm going to divide by u so that I can figure out what my other factor is. So again, like I told you guys before, write down your GCF, and in the parentheses is the result of your division by the GCF. U squared divided by u is u, and u divided by u is 1. I need to set this equal to 0, and I am ready to split it up. U needs to be set equal to 0, and u minus 1 needs to be set equal to 0. I don't have to solve the first one, and the second one, the u needs to be isolated by adding 1 to both sides. Once you have reached the u, you need to resubstitute back into your trig function value. Your u, you assigned it to be cosecant theta, so revert back to trig. Cosecant theta equals to 0, and cosecant theta equals to 1. Now here's the thing, okay? I want you to always remember the following. To the right, I want you to always remember that any time you end up with a secant or a cosecant trig function, I want you to take the reciprocal of both sides before going to your unit circle. So here's what I mean by that. Notice I ended up with a cosecant in my u substitution, right? And following into finalizing my equation, I want you to take the reciprocal of both sides. Well, what is the reciprocal of cosecant? You guys know this. We've had our formula charts for forever. The reciprocal of cosecant is sine. So instead of cosecant, I'm going to change it to sine theta. Okay? And then I need to take the reciprocal of the number 0. Now you guys know that the number 0 is the same thing as saying 0 over 1. So if I take the reciprocal of 0, sine theta is going to be 1 over 0. Let's do it the other one. Cosecant theta becomes sine theta. We know 1 is just 1 over 1. What is the reciprocal of 1 over 1? It's still 1. 1 over 1 is 1. Okay? So we are going to go to the unit circle to find the angles where sine theta is going to be 1 over 0 or sine theta is going to be 1. Okay, so here we are examining our unit circle. Sine theta has to equal 1 over 0. Now we know that sine means y values, okay? We're looking at only the y values. So where is the y value 1 over 0? Now what you need to remember is that 1 over 0 means that it is undefined. Anytime you divide by 0, that means it's undefined. And so our unit circle is not going to have to deal with this equation because we have y values defined in every single coordinate. What do I mean by that? Defined means that you have value, okay? This is my y coordinate. This is my y coordinate. Every single one of my y coordinates are defined. They are not undefined, okay? So for our first equation, where is sine theta undefined? Nowhere. So this problem is just not an applicable solution. There isn't a theta that would yield an undefined solution, okay? Why? Again, every single angle has a y value. You can see the y value, okay? Now, in the next one, sine theta equals 1. Where is the y value 1? Well, let's look. It's not here, it's not here, it's not here. Okay, so here's the first one. Here the y value is 1. And we just keep going around the unit circle, and that's the only place where y is 1. So here, theta, the radian angle is to 90 degrees is pi over 2. That's the only answer to this problem, one angle. So going back to number 4, the only solution to equation cosecant squared theta minus cosecant theta equals 0 is theta being pi over 2. There's only one angle measurement. Okay? All right, so again, if in this situation, what I was trying to establish with you guys, if you end up with a secant theta equation, convert it to a cosine, and if you end up with a cosecant theta, convert it to a sine, because these two functions are reciprocals of one another. Let's do question number 4. And I meant question number 5. So here on question number 5, you're going to notice 4 secant squared theta minus 4 secant theta minus 8. The trig function for secant is mentioned more than once. So again, use the substitution process of letting secant be u. So I've rewritten it. What do we do next? We look to factor using GCF. Okay? Our GCF in this problem is only going to be the number 4. Everything is divisible by 4. So pause this video and go ahead and rewrite it in factored form, and then come back to me. So this is what you should have written. 4 times the u squared minus u minus 2. You identified what the GCF was, and you had to divide everything by 4. And when you did that, the answer of your division was put inside the parentheses. But you're going to notice that we can't apply the zero product property yet, because that u squared minus u minus 2 still needs to be factored. We need to factor this trinomial. So recall, when a trinomial is written in ax squared plus bx plus b plus c form, what your questioning technique is going to be, especially when your a is 1, okay? When a value is 1. And in this problem, our a is 1, okay? And when I'm talking about a, I'm talking about the a right here. That's your a, your b is this term, and your c is this term, okay? So let me write this down. A, B, and C. So the questioning technique for your factoring was what times what equals whatever your C value is, that at the same time adds to be your middle term, B. Okay? Because recall, what we're trying to do when we're factoring trinomial is we're undistributing. What binomial times what binomial is going to give me u squared minus u minus 2. In my problem, the c is a negative 2 and the b is a negative 1. So what times what is a negative 2 that at the same time adds to be negative 1? So if you guessed, negative 2 times 1 and negative 2 plus 1 satisfy both of those equations. So my factored form will be u minus 2 and u plus 1, which were the two options that I wrote in green on the right. Now we can apply the zero product property. I've set them up equal to 0, and then I solve for u. Once the u has been isolated, revert back to trig. So we are ready to use the unit circle. But remember, big star here, big star over here. Remember I told you guys, when you end up with a secant or a cosecant equation, I want you to take the reciprocals of both sides. The reciprocal of secant is what? It is cosine. So I'm going to change it to cosine theta. The reciprocal of 2 is what? Well, 2 is the same thing as 2 over 1, right? So what is the reciprocal of 2? It's 1 over 2. Secant, switch it to cosine. What's the reciprocal of negative 1? Well, negative 1 written in fraction form is just negative 1 over 1. And if I take the reciprocal of 1 over 1, it's still 1 over 1. So secant equals -1 becomes cosine theta equals -1. There isn't any changes in the flipping. So let's head back to that unit circle one more time. So cosine, what does cosine mean? When we think of cosine, you are thinking of the x values on your unit circle. So we're just looking at the x values. These are your x values, okay? X comma y, the first coordinate value. So the first equation is cosine theta equals 1/2. You are looking for where is x existing on the unit circle when it's 1/2. So if I go and look around my unit circle, I notice 1/2 occurs right here. I notice that 1/2 positive occurs right here. Okay, so those are the two values where x is positive 1/2. So next, where is x going to be -1? So I look around my unit circle at all the x values, and the only time x is going to be -1 is right there. So our theta is pi. And you're done. For this equation, we had 3 solutions. So going back to our original problem and bringing back our answers to this page, there is the finale to this video lesson. Thanks for watching, and good luck with your practicing.